So as Alexei said, I work for Verizon. I'll invite Chris Webster to the stage in a little bit. But the way this keynote came about is we ended up submitting a proposal for a regular session. And then Alexei reached out and said, it's a great topic. Do you want to do a keynote? I think he felt that the session was not technical enough. So he put us here. So here we are. The topic was about kind of Scala and using Scala as a means to build a reasonably sizable distributed system, a platform. And the time we started ONcue a few years ago, when I joined them, we were a really small team. So there was a lot of pressure to build both the product and the team from scratch. So I often wonder, when I kind of step back and think about it, if the choice of the language, picking Scala, had anything to do with our time to market, right? So that's kind of where this thought came, is to kind of share some of the experiences and challenges that we kind of surfaced along the way. So ONcue, as Alexei said, was started at Intel and was bought by Verizon last year. And we are building an over-the-top video platform. So when my team is responsible for all the backend server platform that's hosted in the cloud. So when we were looking at technology choices, and to be fair, some of the management team that had started this project were ex-Microsoft folks. So they actually felt very liberated to be able to pick any technology to build this product from scratch, right? So it's fascinating if you come from certain companies where there is mandate to use some very specific company-wide technology. It's amazing to come out there and look at all the options. So when we were looking at the various choices, Scala kind of stood out for many different reasons, right? Just the principles around the functional programming, ability to write concise code, kind of the principles on immutability, and because we had to build a scalable platform, kind of the design patterns around asynchronous programming, all of that was appealing. And the fact that it's a JVM-based language was comforting. I worked at Oracle in the Java group for several years, so the JVM option is always something that feels comforting. So Scala was a natural choice, kind of in that regard. So just to kind of give you a sense for the size of the product that we are developing, we have about close to 200 services out there, and these services are essentially many of them are client-facing, so any kind of content management, user management, kind of personalization of that, any kind of data that any of our client needs, so are served by many of the services. And then on top of that, since I talked about the video platform, we have recommendation engine, all the advertisement capabilities for dynamic ad insertions or ad detection, and all the data delivery pipes, both the pipes that take in the data and do the analytics and the reporting. Everything is Scala code. We have lots and lots of Scala code in our product. And it's a pretty reasonably sized developer team as well at ONcue. And we are kind of rapidly doing development, so we kind of exercise our muscle to go as fast as we can, so we do several deployments in the production environment as well. When I said a video platform, you can just imagine any other application that you're used to, right? So the type of products that you'll be seeing coming to the market would range from our own built first-party set-top boxes to mobile devices to apps that runs in other consumer electronic platforms as well. So it's has an opportunity, and Verizon Wireless has a huge customer base, so kind of the mobile offering, the expectation is we have a lot of people, I'm sure a lot of you have Verizon subscriptions, so hopefully use our product there. So the expectation is there will be a lot of usage, and with that, then the constraints on the platform to make sure it's fast, it's available, it's reliable. So all those qualities kind of come into the picture. So what we'll do right now is to kind of walk you through some of that. So let me invite Chris Webster to the stage. Chris is an associate fellow with Verizon, and he manages the team that does the client-facing services. Hello, Chris.
Hey, everybody.
And so we will hopefully do it in a little bit of a fun way. We'll do it in Mythbuster style. So what we wanted to do was probably throw some popular myths out there or make up our own. And we'll talk about our experience, and then we'll say whether we prove or bust those myths. Does it work? Yeah. All right. You want to kick us off with the first outrageous one, hopefully out there?
Sure. So I think this crowd is already going to think these are all busted anyways, but that's OK. We're going to go through the motion. So at Vidhya, as you mentioned, we have lots of developers writing code, and we have multiple web services. They all have to scale. We have lots of use. Is Scala really enterprise ready for the enterprise? Not enterprise ready, but ready to be used within a big development organization. What do you think?
All right. So I'm sure many of you get asked that question if you are with big companies. Why Scala? Why do you have to do this? We hear this all the time. Especially as a manager managing a team doing Scala, you often have to put that, you got to go batting for your team. It's not easy to stand there and explain which of the next version of the refactoring you're going through, or some issues on some library you're trying to adopt has to do with Scala as a programming language, as opposed to just the fact that we are building a scalable platform, right? So one of the things that naturally occurs when you adopt any kind of open source technology is you're often looking for libraries or frameworks that help you get things done, right? So it's either you're looking for a JSON parser, or you're looking for suitable web frameworks in our case, or any kind of logging frameworks or libraries. We are often looking for options. And it's not something that's unique just for Scala. Even in the mature language, I'm sure most of you have to kind of go through that exercise at some time or another. What we observed, though, in the case of Scala, since it was new at the time we started adopting, the ecosystem was still maturing, and there was kind of rapid consolidation happening in several of those libraries, right? Good examples were code coverage tools. We are struggling to find good code coverage tools. The plethora of JSON parsers that are out there. So the size of the team doesn't lend itself to go off and look for libraries, especially when we try to solve common problems across our platform, right? So one good strategy that we have adopted that seems to work well for us is to have a very core team go and look for options to solve some of the very common problems across this large system. Right? So concrete example I'll give you is when we migrated off of a third-party hosted cloud database to our own Cassandra clusters, we had to think about the database driver. That was the first problem. We ended up adopting a library, and we soon got into an issue where it didn't have the community support that's needed. Remember the Hector train that we went through? Yeah. And then we ended up adopting, DataStax as a Cassandra company, their own drivers, and that worked well for us. And Dean was there with us, trying to help witness the journey of all the madness we went through with it. So we had an interesting data access layer that we were using across all our services to talk to the third-party hosted system. So the first effort we took is have this core team build this new data access layer against our Cassandra clusters. So outside of hunting for the libraries, the core team had to understand the various use cases of how the database was used, and we had to make sure that we prototyped and understood the pros and cons of what we were trying to build. Once we got that, then the next problem is understanding what is the performance overhead of this new library. So we took some of the industry benchmarks, we ran them against the Cassandra cluster, had a good baseline, and then we made sure that we were not adding too much overhead by our own library. And then we had to compare against our older data access layer on this other database we were using. And then once we got to a good point, we said the rest of the team was able to just go and make a change. And all this time, the folks on the other, who were working on the other systems were thinking about how they were going to migrate their business logic to the Cassandra database, thinking about data model and the proper way to design it, as opposed to worrying about these things. And we ended up following that same model when we go through any kind of big changes. Every Scala upgrade and Play upgrade takes a long time because of just the amount of systems and code base that we have, so we kind of end up adopting that as a strategy. In a distributed system, again, failures are inevitable, so some of the design patterns around dealing with that, I believe, is completely agnostic to the programming language of choice, right? The systems have to deal with failing gracefully. So in our, one of the common library we have, where we have a service-to-service library that does both the discovery of the endpoint you want to talk to and also does the communication across these services. We have some patterns that we have built for circuit breakers, right? So if the endpoint you're trying to reach out to is slow, then this knows kind of how to deal with timeouts or whatnot. And the fact that the other endpoint is not reachable anymore means we have a backup strategy to make sure we are not DDoSing our own systems. The DDoS problem is all about our own bad code doing all bad stuff. So there we kind of put that design pattern and we deal with it in some of the common libraries. So that, I believe, has nothing to do with Scala as a programming language. But there are some patterns in Scala that helps with thinking through failures, right? So the Scala composition model is a good way to model failures. Again, making sure that we are always keeping immutability in our mind when we write the code means we are not dealing with some of the nasty bugs out there. And then the non-code related stuff, right? When it comes to building a resilient platform. And that has to do with the kind of the operational side of things, right? So when you think about the operational side, we are big users of Netflix's Simian Army. So we induce both latency and failures in our production system, and we make sure we test them for how we expected the systems to function in case of failure. So test, that really helps. And also, kind of needless to say, a lot of the people do this, which is go with, kind of redundancy as a strategy to deal with failures, right? So making sure the stack runs on multiple data centers, and then you deal with the problem of how do you keep the data in sync? How do you, make sure that the requests that are coming into a data center, in the case of failure, fails gracefully to the other available ones? So getting that all right has nothing to do with Scala as a programming language. And the last one, some of the basic things, let me just get them out of the way, right? So having a continuous build environment or integration environment, make sure you have end-to-end tests that test the common scenarios, like commonsensical things, and make sure you're running them on every build so you can catch regressions ahead in your development cycle as early as possible. Really helps to address all that. So those are some of the basics. Outside of this, something that I'm passionate about and has worked well for us is really encouraging the dev team to do deployment as often as possible, right? So the act of taking your working code from your laptop and dropping it with the rest of the components in a distributed stack is really important. There are a lot of things that we find by just going through that exercise. Right? So the performance characteristics is very different. Or just how the interaction model works in the distributed system means there are lots of things we find that we don't normally find when you're just building things in your local environment. That habit of going through and exercising the deployment muscle really helps. So some of the examples, we have a fairly good automated pipe that takes our build from a less restrictive to increasingly restrictive environment, if I have to put it that way. And so we find limitations on that when we build a new system. So, Andrew talked about having people doing multiple things. We try to do that too, but as you kind of scale the team, you do get into some lockstep or bottlenecks, right? So the sooner you find a dependency that you're waiting for someone else to change their library or code, the faster you will have a path of taking your stuff into production, right? So that becomes kind of unavoidable in our case. As much as we try and have people jump on various things and work on, there are some areas that really becomes hard for everybody to jump on and do things. That kind of summarizes most of what I wanted to say on this topic. What is your verdict? What do you think, Chris?
I think it's busted. I think we've been using this for a long time, as Vidhya mentioned. It sounds like it's busted to me. What about you guys?
Yeah, that's
busted.
Good.
Okay, we'll bust it. All right. You want to kick us off the next myth?
Yeah, so the next myth, well, there's a lot of Scala experts here, but the myth is it's hard to find people who can write Scala. It's going to be impossible. There's only a few handful of people all over the world, and you're going to have to get them. You're going to have to fly all over the place and get them. What do you think, Vidhya?
Right. When we started ramping up the team, and Chris knows this well, he was one of the very early hires in the engineering group. We were so worried about the ramp-up time needed to learn a new language. We were hell-bent on finding people who had Scala skills. It got very, very difficult. I'm talking about 2012. Things have changed a lot just in the past few months or so. But that said, it's really important to build a team that kind of works well together. We can have super sharp people with very good language skills, but if they have an attitude, that kind of ruins the experience for everybody else. So we used to have comments like, oh, we want 4Xers, we want 10Xers, we want people who walk on the water. And we still kind of do that, but the fundamentals we look for when we look for people is, are they good people to work with? It's at the end of the day, it's the team, right? And do they have good foundational aspects? Do they have a good aptitude to learn, right? Do they have good algorithm background? Are they familiar with distributed systems? Have they done high scale? Do they understand the need to do performance optimization? So those are kind of fundamentals that we look for in the team right now. And so, on one side, you have these really good language enthusiasts who are very adamant about making sure the right idioms are used in the right use cases. On the other side, you have these people with lots and lots of experience doing things for real, and they kind of know a lot more about, a GC or internals of the JVM, and how do you troubleshoot, and how do you profile your system. So that kind of mix is really good, and it's been working very well for us. So that's kind of where we have shifted our hiring strategy at this point, I have to say. And then having picked Scala as something that is new for us, I don't think the community took us seriously, right? Whether it's Verizon or Intel, it's kind of a corporate thing. So starting to feel relevant in the community means that we needed to get some of these key hires on board. One strategy that worked for our very first hire that we had is our ex-VP flew out to UK, had a breakfast with this guy, and that was enough to convince him to come and join us. And once we kind of applied some of these strategies and had some core folks who were relevant in the community here, then it started to grow kind of organically, right? There are lots of our folks who we kind of brought in that way, who are there doing technical sessions or at Scala by the Bay or Scala Days, or when we host the meetups. And we have open sourced several of the Scala libraries that we have been developing in-house as well. So I see Stu there, we have Runar, we have Tim. You probably have come across those guys giving talks at several Scala conferences. And next time you attend Tim's talk, ask him how the breakfast was. And though a lot of the developers are exposed to multiple languages, the learning curve does differ for different people. There are people who come in and day two, they're ready, they check in their code, they built the functionality, they feel like they got it. And there are people who take a little bit longer to kind of get a feel for the new patterns of doing things, and it takes a while. But as someone on the management side, something that is really important is to make sure you are making all the venues and everything available for the dev team to feel like they can learn and conquer this new thing that we are marching towards, right? So we do a lot of Scala trainings. We had type-safe consultants sit right close to us. You remember that? Yep. And so nothing like writing a piece of code. And I remember, people go around and sit with this expert and like, can you look at my code? Can you review what did I do wrong, not wrong? So that iteration helped a lot in kind of getting out of that resistance mode, and that worked extremely well for us. So, meetups, and we do cross-pollination across the different groups in Verizon. We are not the only group. There is a big group in South Bay also doing machine learning. They're big, heavy users of Spark. And so we make sure that the teams have an opportunity to cross-pollinate and learn from each other. I kind of gave this out. I believe this one is busted as well.
I think it's busted. What about you guys? All
you
right.
don't have a choice other than agreeing with us.
We already busted it anyway. So.
All right, Chris, you're going to do the next couple.
Yep, I'll do the next few. I need a cheat sheet though.
All right, so this one is another interesting one, right? So does picking a new language or picking Scala, do you think it has had any influence on the culture? And since I have to phrase it like a myth, you think it had a positive influence on our culture?
So when I first started, it was pretty recently after Vidhya joined, and we had a mix of a few people that knew Scala really well and a lot of people that were coming from either Java, or we had Ruby on Rails. We even had some C and C++ developers who were on board, and everyone was kind of learning together. So part of the interesting thing about learning together is that people aren't afraid to ask what might seem like a dumb question when you've been doing development for 15, 20 years, and you ask, oh, what does double equals mean in Scala if you're coming from Java, right? It's a little bit different. There are these things that are a little bit different. And since everyone was kind of learning together, we had recent grads, we had lots of experienced people. Everyone was kind of working together a lot more than they would if they're experts in the domain. They're just going off banging out code, and everyone's kind of remote and siloed, and everyone's doing the job, but they're not kind of cross-pollinating. And so since I think we started a brand new kind of greenfield project, and a lot of people were learning the language for the first time, it was really kind of empowering to have everybody working together at a level that they probably wouldn't if we started with, if everyone's coming into an existing project and we already had experts, they kind of would have just got off and did their pieces. The other interesting thing about our Scala in general is that it seemed like the experts that we have, and even the new to become experts, were not just interested in learning, but also in teaching. Like Stu, he's sitting over there, I'm going to pick on him since he's here, I don't want to talk behind his back, is really good. He has a brown bag session. We have another person on our team that has a weekly tech talk, and it was usually just Scala topics, but he's expanded it out to do other things. And it seems like that has been just a lot more prevalent. I think one is that people are interested in learning from people who have more experience in different areas. And I think create a new language where there wasn't a lot of expertise in our team, or there was pockets of expertise, was one of those things that kind of drove that. The other thing is, Vidhya kind of alluded to, is that we had a lot of people that weren't Scala experts, but that did have a lot of experience in Java and performance profiling and Cassandra and those kind of things. And so when you kind of bring these people together, really everybody has stuff to learn and everybody has stuff to teach. So everyone really feels like if somebody can teach, and you see me talking up here, I have to do some of the sessions too. They force me to do them. That is the teaching part of it, not the learning part. I go because I like to. The teaching part sometimes is a little harder. But having this concept of everybody has something to learn, everybody has something to teach, really has kind of permeated at least my team and I think more of the environment that we have. And just a couple of the other examples that we have from the team is that we had one of our data scientists who had done a lot of MATLAB and R programming was seeing, everyone's picking up Scala, and she started to do it and became a good Scala programmer. We had a very experienced Scala developer, I kind of mentioned this earlier, who's running these technical sessions, these bi-weekly technical sessions, and kind of take it upon himself to get interesting sessions, and if he doesn't get one, he does it himself, so that's always good. And one of the interesting thing about Stu's session is that there's one engineer on the team who is very diligent and does every single homework all the time, and she's the only one who's been able to do that and attends all of them. So really the driver in this case for the positive culture was definitely the new language, but it doesn't have to be a new language. It could be around some other new technology or something that kind of everybody gets to learn together. The reason I think Scala was very important is that it seems like the more you learn about Scala and functional programming in general, the more you don't know. So I'm at the point where I know a lot, but there's always a lot more stuff that I don't know. And when I talk to Stu and some of the other guys on our team, I realize, hey, there's really a lot that I don't know. And so I think it's those things that really drive our culture around here. What do you think, Vidhya?
Well, I think you made the point that a lot of the behaviors you see, it's just not Scala specific, right? And I think sometimes we forget what it takes to learn a new thing. If you've been working on, let's say, Java for a long time, and you get comfortable about it, there's no empathy for people coming in and learning something new. I think that's fact, right? It's just like, you don't get this? That's the kind of the feeling that comes across. So I think, everybody is in the same leveling field, and everybody is learning. So I believe this is plausible. I think there is something to say about how our culture has turned into a very collaborative environment thanks to picking something new. So let's declare this plausible.
Anybody have a second? Okay. We're going to go on anyway, so. All right. The last one.
All right, this hard one. Scala's hard. Think it's hard?
So this is an interesting question. As I mentioned before, when we started adopting Scala, we had a lot of people from, a lot of Java programmers, some C programmers. And, functional programming is certainly different, right? So I think part of it is that people in general are resistant to change. It's not just about your programming language. It's about try to take away somebody's editor, tell them they can't use VI anymore, or tell them they can't use Emacs, or whatever their favorite IDE is, and you'll probably have a resignation within a few hours. So you're talking about shifting a programming language, which people feel pretty religiously about in a lot of cases, I think. So a change from coming from Java, you're not just talking about the language patterns, you're also talking about tool changes. So in Java, if you're using Ant or Maven, you're probably now going to be using SBT, which is similar in some sense in the dependency management, but it has its own flavor of how you have to do things. The programming language, the APIs that you have to learn, the idioms, patterns, we had lots of mentions about Scala Z and some of these other functional programming topics. There's a lot of new stuff to learn, and it's kind of scary to say, oh, I was an expert in this, and now I'm not going to know, a recent college grad is going to know more than I do about this, and that's true. But you have to, think about, is it just the scared of learning something new? Is it just being scared about learning something new, or is there more really to? The language is hard; it's impossible to learn. I don't think it is. Obviously, there's a lot of people here, and the adoption is increasing, so that really, I don't think that can be true. I think the other part that's interesting is the expressiveness in Scala. So usually you can write less code to do about the same behavior or more. But part of this expressiveness is you get a lot of, you can create DSLs and fluent programming. And if you're not familiar with the DSL and the language, that kind of makes it tough. Like the first time you look at something like a Scala test or a Specs 2 and you're reading this, it's like, okay, why are these words in the middle? I'm used to having a dot and a parentheses here, and it just doesn't make any sense to me. But after you learn it, you say, okay, this is a domain. I understand that you don't need to use the dot in this case, in that case. And again, it's an adjustment. Once you've done it once, then writing those tests the second time, or maybe not the second time, after a few times, it becomes a lot easier. So it's really this getting over the hurdle of being scared, just like public speaking. Nobody wants to do it, but once you do it 15 times, you're a lot more comfortable up in the front. The other thing is there are some interesting things if you come from Java. There's some, it's kind of like Spanish and Portuguese. They're about 50% similar, but the 50% difference usually bites you. So for example, return in Java is just fine. Return in Scala there are some problems with that, so you don't generally want to, there's the double equal in Java. Okay, you just don't do that, but in Scala you do that. There's just a few things that you get burned on the first few times. It's hard because you don't know, or forgetting to put if you don't declare the return type of method and forgetting to put that equals the very first time and wondering why your code doesn't compile. It's returning it, why does that work? I don't know, but you learn the hard way once. Hopefully the compiler and tools help you, but that first time you hit it, it's just hard, and it's hard because it's different. The other thing, like Vidhya mentioned, using a kind of core set of libraries where you have a lot of examples. Some of the stats up there, we have hundreds of services. So, if each service kind of took its own set of libraries, it's really hard to jump across 3 different services and know what they're doing, even if you're an expert in the language, if all the domains and libraries that we're using are different. So we kind of tried to standardize on at least some of the libraries so you can move across services and look at the code and at least read it a lot easier than if everyone was using their own libraries and idioms. And finally, I think the last thing that we kind of adopted is you don't necessarily need to use every single language feature just because it's there. There are cases where you do, but you don't have to do that. And so using judgment, that problem never really goes away. It kind of stays there. The last thing that I'd like to say about whether Scala is hard, since we're creating a lot of web services, we get a lot of high-scale systems. It's very nice that immutability is a lot easier to do than mutability. If you don't do anything and use a list, you get an immutable list. From the services side, the worst bugs that we get are memory leaks. Nobody wants to get a memory leak, even a small one. You might catch it in testing, but some of these ones, a couple of bytes here and there, after billions of calls, you get the dreaded out of memory, and then your whole system is crashing, and you're rolling, restarting, trying to figure out what the bug is and get everything working. So that, for the service side, if you really treat a web service API if you think about that as a function, most of the stuff should be immutable. Yes, you want to do some caching for availability and et cetera, but if you minimize that, you will reduce the number of calls you get in the middle of the night or the weekends or the times when you don't want to get those calls. So for me, that's making it easy to do the right thing is the language kind of guiding you down the right path. And so I think it's busted. I think there are certainly more things that everyone can learn, but I don't think Scala as a language, if you apply yourself to it, is any harder than any other programming language. Look at, even considering to Java, who's read the Programming Puzzlers? There's multiple books, right? It's not just one. There's multiple books. So you can pick a language and pick the puzzler, C++, effective C++, right? More effective C++, more effective C++. So that I think it's not just Scala, it's programming in general and learning the concepts. What do you think, Vidhya?
Agree with you, right?
And we already know you guys think that you're here, so.
So that's all we thought we could share this morning. Thank you for the opportunity. Appreciate it.